So in this case, we are going to consider as part of our revisions and introductions, as we are working, preparing for our exams, which are ahead of time, we need to understand the basics of our number patterns, starting from the grade 10 concept, which is the arithmetic or the linear sequences. We had this part actually from our grade 9. We had been working with such an arithmetic, which we are understanding from the linear concept that we are having here. Remember, if we are given a linear equation, y is equal to mx plus c. So, in the actual sense here, we do understand that we have got the y-intercept, which is our c, our m, which is the gradient. And as we consider the m and the c are constants, which are to be found. So let's take it now when we are referring to as an arithmetic, a linear sequence. It's now a sequence where you are to find the nth term representation of our Tn. Remember our Tn. So we were just writing this Tn is equal to, you can use the An plus B, some they were using Bn plus C, depending with what you were being taught or what you're being having in your previous grade. So if we are to consider actually to say, where was this taken from? This is what we need to understand. The Tn is equal to An plus B presentation merged to the y is equal to mx plus c. As we can see, it's just one and the same thing. So as we had got m as the gradient, it is the same presentation of this a, the x just as the n, the b as the c. So if we just represent this way, we just went straight forward to the linear representation that we understand. But actually, this part was being taken from the Tn, which is equal to A plus n minus 1 times d as the formula of finding the nth term for any arithmetic or any linear sequence. All right, what is it that we are referring to as an arithmetic or a linear? Remember, this is the sequence where we have got the common difference throughout. When terms are being represented, this is the first term. We have got the second term, the third term, and so on. As terms are being presented, there is a common difference between the terms. If I subtract this one, T2 minus T1, I'm going to obtain the D, which is the common difference. The same thing, if I subtract here T3 minus T2, I'm going to obtain that D. That is the concept. So D, this part, when we are given terms, if this is common throughout, it means the sequence that we are given is being referred to as a linear or an arithmetic sequence. There is a common for those terms that you are given. The difference that you're going to, if it is the same throughout, that's an arithmetic. Remember that. So we were doing, it was just like shortcuts because we had a formula already represented. We had a formula already represented to us. But in the case of the formula that I wrote here, it is telling us or giving us a lot of things that we need to understand in order for us to apply this, because it is just like a slight difference from this presentation. So what we need to know is that when we are given from this formula, this one, not from this one above it has got its own concept or ways of using it. But as you are using this formula, the A that we are seeing here represents the first term. So A represents the first term, meaning to say that's our T1. That's our first term. The first term that will be given here, that is your A. The D representing the common difference. That is the common difference for the given arithmetic sequence. So we've got the common difference here, which is taken from where? The difference is T2 minus T1. So you can actually say D is equal to T2 minus T1. Someone can do this by finding T3 minus what? T2. So it is the same thing as given as T3 minus T2. It can be T4 minus what? Minus T3. Anyway, it must be the same throughout. The common difference. The common difference. Same throughout. And we have got the N, which will correspond to Tn that you are calculating. We have got the N, which is like the number of terms. Number of terms. So thus giving us the position of the nth term, like is it term 1, is it term 2, is it term 3, like that. So what does it mean? If I am given Tn, we are talking about for any number of terms. So if I write this as T3, we are talking about when our n is equal to 3. When our n, remember this is Tn, so n is 3. So when you are to find T3, it is just like finding the third term. N is equal to 3. Tn. So if it is given as T5, it means in that case, our n is 5. The n that you are supposed to substitute there is what? Is 5. So if we are to use this formula, at the end of our presentation, we are going to have something exactly in this format that is given as an plus b. Like I was saying, some here they use bn plus c, just any presentation. On this presentation of an plus b, we do not have this part corresponding here. The only thing that corresponds is the n, the number of terms. The b, the a, they mean something different from this formula. Remember this as we used it in our previous grades. We understand that on that presentation, all right, let me just write this because this is a recap here. So if I am using from this formula, we do understand that our a in this case, all right, so I've got this a here. A is just like the gradient, that change in y over the change in x. So in actual sense, on this sequence, A represents that common difference in actual sense. Remember here we said when we are taking from this Tn, the D is the common difference. The D is the common difference. Here A is our common difference. This is our common difference if you are taking it from this way. So maybe for you not to have confusion, you can have the Tn is equal to Dn plus C, whatever way that you understand. But I'm just taking it from the previous presentation that you used to have from your grade 9, from your grade 8, and so on. A was your common difference. From the fact that you're being told that it's a linear, you find the difference, T2 minus T1. You know that, okay, that is your A. Then B, the N here being the number of terms, just like the previous case, this one is not going to change. Number of terms is just a variable. We just take it as a variable. It's not a constant to be found. It is a number that you must be given. The constants are A and B. So A, which is our common difference, this one, it is also a constant. Remember, any constant is a value to be calculated. You must determine that value of A and also the value of B. So B, in the normal presentation, is just like, okay, this is the y-intercept if it is a graphical presentation. So in this case, the B, we are not going to give any meaning to it. But the question is, we must determine that value of B. It is just a normal value, just like the C that we had from y is equal to mx plus c. Okay, they're just like we are having our y-intercept. So in this presentation, we are not going to emphasize much on that B. But we must calculate the value of B because it's a what? It's a constant. So this one, it is just a constant, which has to be calculated. So we can calculate the value of B by substituting any corresponding term, like T1 is equal to 3, T2 is whatever that you're given. You can substitute that N and the corresponding term to find the value of B. So it's a constant to be found. Remember how we calculated this from a grade 9. You can use any combination or any term to calculate what? To calculate B. All right. So to calculate B, we are going to use any term. So this is in your hands in terms of your revisions. This is in your hands. Which formula are you going to use and according to your understanding? But this is what we had previously. We have been working with this type of a format. So most of you maybe are used to that. But I want you to understand this as well in as much as you can. The second part. I want you to understand this because it is your starting point of your grade 12. Because in our grade 12, remember, we shall be having series. Here we are just focusing with a sequence. So understanding these indication of A, N, and D is going to help us a lot. Because as you continue the series, we shall be working with these A, D, and N. We won't be having this. So it is just for you to, like a recap, for you to just understand. So I'm going to present some of the questions that we can use these formulas and see which one can you opt for. But like I said, I want us guys to work more with the second formula. Yes, the first one, just like you had it, guys, from your grade 9, grade 10. Now it's time for you to focus with what? With the second formula. So we have got the first question that we are going to consider as we have got this part we are given that consider the following linear number pattern. Already you are told it's a linear number pattern. So in terms of exam, because we are going to have another type of a sequence later on in our classes, if they do not mention that it's a linear number pattern or it's a linear sequence, then you must have to test, is it linear? If it is not, then you go for a quadratic. But if they mention like this, you already know it's a linear. That's an arithmetic. Where we do understand for this one, we must have a common difference between the given terms. So we have got the sequence given the terms that are 3, 4, 5, and 6. Representing what? The first term, the second, the third, the fourth, and so on and so on. So we are told from this, A, determine the nth term, and hence 110. All right, let's start with the nth term. The nth term. This is the presentation or indication of our Tn. So remember I said we've got two formulas here. The one that we were used to all along. Okay, let's start with that one and see. From the first formula, we do understand that our Tn is given as An plus B is going to just depend with what you've been using before. Is it Bn plus C, whatever that you have there. But what you do understand is that the part that is multiplying n there, the A is the common difference. As we are told it's a linear, there's a difference between the terms. What is the difference? 4 minus 3. That's T2 minus what? T1. 4 minus 3, which is 1. 5 minus 4, which is 1. As we can see, there is a difference of what? Of 1. That difference, the common difference, is the one representing our A. So it will be easier now because we're just going to have Tn is equal to 1n plus B, of which 1n we just understand this is n. So we've got 1 times n, which is n, plus what? Plus B. Remember, B is a constant, just like A, which had to be calculated. Remember, our A is 1. So just like A, we must calculate the value of B. From where? From substituting the corresponding now to say T1 is 3. So you substitute any, T2 is 4, whatever that you want. So let's take T1. Our T1 is equal to what? To 3. What does it mean? It means when n here is 1, remember it's Tn. N is what? 1. For the value of n, if I have to substitute n as 1, the answer that I'm going to get there is supposed to be what? 3. So we can substitute that one direct to say our Tn, which is T1, is 3. So 3 is equal to, on a condition that n is 1. On a condition that n is 1. So you're going to substitute in place of n, that's 1 plus what? Plus b. All right, so that's it, plus what? Plus b here. Remember, Tn and n are the ones that we substituted. We must calculate what? The value of b. So just take this to the other side of the equation. That's 3 minus 1, which is what? Which is 2. So that's 2 is equal to b. So therefore, we can rewrite this now as Tn is equal to what? Remember, we had already this part where we wrote Tn is equal to n plus b. So we can start from there. N plus our b, which we calculated now. Remember, our b here is 2. So we want this part and also this one. So we take the Tn, which is equal to n plus what? Plus b. This one. So meaning to say, that's our b, which is what? Which is 2. We have got our answer there for Tn. N plus 2. So this was just like our grade 9, grade 8, something like that. Let's go back to the other formula that we presented and see how we can obtain the same answer from a different presentation. When Tn is written as A plus n minus 1 into D, what does it mean? All right, let's take that one and see. From this formula, you must be very, very careful. Like I said, this is the one that I need you actually to, I want you guys to work with this one in as much as you can, because this is your understanding of your grade 12 mathematics. If you understand this, it will be easier as you are going to continue from your grade 12. So here we said A is the first term now. Here you must be very careful. A represents our T1, the first term. So meaning to say we already have that one on our formula, which is 3. A is equal to 3. Okay, our first term. We also know about the D being what? The common difference, this one, D. So already from where were these subtractions, 4 minus 3, this and that, we were calculating what? The common difference, remember here. This is our common difference. So we already have the value of D, which is what? Which is 1. A and D, these are constants. N is a variable, meaning to say we cannot calculate that N. It is just like here. We cannot calculate the value of N. We just write as it is like that. It's a variable, that one. So as you have got A being the first term, D as your common difference, substitute this into your formula. So Tn is equal to what? We substitute. What is our A? Our A is 3. All right, so our A is 3 plus N minus 1. Remember, this is just as it is on the formula, did not change. The D being what? The common difference. So we are going to have our D here as our common difference. That's it. Knowing this formula, guys, is very easy because you just need to substitute into the formula. You simplify further. So it is now for us to simplify and see if we are going to have the same answer just like before. All right, so let's simplify and see. So our Tn is equal to just the constant here as it is. So that's 3. All right, we can expand this bracket. As we can see, there is a 1. Expand times n there. So that's plus 1 times n, which is n. We multiply 1 times negative 1, which is negative 1. All right, the plus here is going to expand the bracket. Remember, expanding the bracket by a plus does not affect anything. Like, guys, it's just like plus 1. It does not affect anything. So a plus does not affect anything. Meaning you say this bracket here is just going to remain as it is. So it's 3 plus n plus and minus. That's a minus. Okay, so we have expanded our bracket. Let's simplify further. There is n, which is our variable, being a positive. Being a positive. You can just rewrite as it is. So that's n. Then continue with the constants 3 minus 1. So that's 3 minus 1, which is equivalent to 2. So this is what we have. Tn is equal to n plus 2, which is exactly the same as what we had before. Exactly the same. It's a formula meant for all linear sequences. It's a formula that is meant for all, as long it is an arithmetic or a linear sequence. So we can use it. Or we can go back to that application that we had before when we were in the previous grades, which is not a problem at all. It's not a problem. Anyway, you can find the Tn. Okay, so that is what we had on determining of the nth term, which is our Tn. So we can use any of the two. So the choice now is in your hands. It is in your hands, guys. All right, so that was our A. We got this, our Tn, as n plus 2. Then they are saying, and hence the 100th term, hence it's a continuation from the Tn that you calculated which is n plus 2. Now determine T100 because n is 100. They're saying n is equivalent to 100. So in place of n, we substitute the 100. So we are calculating T100 like this. That is what it means. Tn. So if it was the first T1, the second T2, the third T3. So we have talked about what? 100th term. So in place of n, we're going to put what? 100 plus the 2 which was already there. All right, so that's it, which is a direct answer here. So T100 is going to be 102. If you add 100 plus 2, that's going to be 102. All right, continuing with the same application or same knowledge of the Tn that we calculated. On part B, they want you to determine which term of the number pattern is equal to 52. Which term, just like the nth, second, fifth, 100th. So when it is 100, it's n. So which term? N is what? Of the number pattern that is equal to 52. So in actual sense, remember we are saying when it is T1, n is equal to 1. So if we do not know the value of n, we do not know to say n is what? We're just going to write as Tn. So Tn is equal to what? To 52. It is the one that we are given. The Tn is 52. So for which value of n that are we going to obtain 52? What are we going to do? We use what we already calculated before. The presentation of the nth term can be used to answer any question. Any question. So if we understand that Tn is n plus 2, Tn is what? It is 52. So in place of Tn, put that 52. You have it. The Tn, the Tn. You replace it with what? 52 in place of that Tn. So it simply means 52 is equal to n plus 2. N is what we need, guys, remember. The Tn is already there. It's 52. So in place of that, 52 is equal to, that's an equation that you need to solve for n. So let us take the 2 to the other side. What are we going to have? That is going to be 52 minus, there's a positive to the other side. That will be a negative. So that's equal to n. So in actual sense, our n is going to be 52 minus 2, which is what? Which is 50. That's it. That's the 50th term. N is 50. As long you have the nth term, you can answer any question. You can answer any question. All right. So we want to consider another part of the questions that I'm having so that we see how we can attempt our typical questions. So there we are given another part. As you can see, it's just one and the same. Consider the following linear number pattern. Like I said, as long it is a linear number pattern, now it is in your hands. How are you going to simplify or work out the type of question that you are given to determine the what? The nth term. So using the second formula, which I need us to focus much on, so you can use the first one because, guys, I've been talking about this since your grade 8 mathematics. I've been explaining this to you. So let us refer to the second one, okay? So Tn from the second one is given as what? Our Tn is equal to a plus n minus 1 times d, where a is the first term. As we are given our terms, this is T1, T2, this is T3, this is T4, and so on and so on. It is not ending, and so on and so on. So we already have our A there, the first term. So A is equal to what? Our A is equal to 3, which represents our first term, and D being the common difference. We are told, guys, it's an arithmetic. So let's find the difference between the terms. 5 minus 3, which is 2. 7 minus 5, which is 2. 9 minus 7, which is 2. As you can see, it is the same throughout. So thus, our common difference is 2. Substitute as it is into the formula. The A as it is, your first term, which is 3, plus n minus 1 times the D, which is our common difference, 2. We substituted these, the A and what? The D. Then simplify. By simplifying, we have our Tn. So that's going to be 3 plus, all right, you can choose to just combine this as it is, plus 2 times what? Times n. This is the plus and the 2, they are together. Or you can just ignore this, work out the 2 as it is, all right, so that you do not have confusion. So expand by 2, 2 times n, that's 2n, 2 times negative 1, which is negative 2. Then from there, we can expand by the positive that we are given. So that's 3. Remember, the positive just going to remain as it is. Positive to positive, that's positive. Positive to negative, that's negative. Okay, so that's, we can collect the like terms working with the constants, 3 and minus 2. So we've got the 3 and the minus 2. 2n is just on its own. So that's 2n, 3 minus 2, which is what? Which is 1. We are done. There is nothing that we are going to do further. It is in its simplest form. So writing this as Tn is 1 plus 2n. 2n plus 1 is just one and the same. Remember, A plus B, it is the same as B plus A. B plus A. There is no effect. So if I write 2n plus 1, if I write 1 plus 2n, it's just one and the same thing. All right? So I want you guys to get used to this one. A plus n minus 1 into D. And as a continuation, they're saying, and hence determine the 180th term. N is 180. That's what they mean. So in place of that, just a continuation. So T 180 means when N is 180, as it is given there. So in place of the N, we put 180. So it's 2n, that's 2 times our n being 180. We substitute the n that we are given there. But we have got what? Plus 1 at the end. So you're going to add the 1. So simplify. This is in your hands. You can just use the calculator at once. So that's 2. You open bracket times 180, close the bracket, plus 1. So that was going to give us 361. Just like that. Hence, it's a continuation from what you just calculated. Continue from there. So you see how you can attempt these questions. It's just a repetition. If you check these questions, it's just a repetition. You see the B part, it is just one and the same thing, just like what you saw on the previous question. Which term of the number pattern is equal to which term? N is what? When our Tn is 241. Remember, already we have got our Tn, which we calculated before, and we said it is equal to 2n plus 1. Just equate the two. Tn There is no way equal to this one. So it simply means these two also, they are equal. Tn, which represents 2n plus 1, must be equal to 241. You have an equation to be that you're going to calculate or to solve for n. 2n plus 1 is equal to 241. These two, they are also the same, as these two represents the same thing. So let's solve for n. We have got an equation here. So 2n is equal to, take the 1 to the other side of the equation towards a plus. So it's going to be a negative, or just subtract 1 both sides of the equation. So that's 240. Then divide by 2 by 2. That's our n was going to be 120. So that's what we have there. So questions can be given in this format. Do revise as many questions as you can. Try to figure out. Revise your exam, previous exam questions. All right, let's check another part. Consider the following linear number pattern. We are already told it's a linear, so there's a common difference on the terms that we are given. All right, so let's see, because we are told here it's a linear. So determine the nth term, just like the previous case. -2, 3, 8, 13. Using second one. All right. So guys, you can use the first one just to cross-check. But let's just try to adapt to the second one. So these are the terms, and so on and so on. Remember the common difference. We are already told, guys, it's a linear, so we do understand a linear. It has got a common difference between the terms. So that's it. 3 minus -2. So it's T2 minus T1. Remember our common difference. So second is 3 minus T1, which is -2. It's already carrying a negative. So that will be minus, which is a positive, and that's 5. Right? 3 plus 2, which is 5. All right. The second one, here's just direct 8 minus 3, which is 5. 13 minus 8 again, which is what? Which is 5. Having these, it's enough. Because already we do understand that our A is what? Is -2. The first term. D, the common difference is what? Is 5. So therefore, we can apply our formula. Tn is equal to A plus n minus 1 into D. So let us substitute what we are given. Our A, that's -2 plus n minus 1 times D, which is what? Which is 5. So here's a product. The D has to expand. So you can just open a bracket like this. All right, so let us simplify. That's -2 plus 5 times n. Going to expand now the bracket. 5 times n, which is 5n. 5 times -1, which is -5. Then expanding by a positive here does not affect anything. It means just going to remain as it is. Positive to 5. That's 5n. Positive to negative. That's a negative. So meaning to say, therefore, our Tn is equal to 5n. All right, considering the constants, the -2 to the -5. So -2 minus 5, that is what? -7. So that's it. This is our Tn in its simplest form. So substituting is not enough. You are supposed to simplify it. Must be in the simplest form. This is the simplest form, just like what we saw in the from the previous questions. With this Tn, we can determine also, hence determine the 259th term when n is 259. Just guys know that is n is 259. Otherwise, you might end up saying it another way. All right. So when n is 259, let us find 259 from the 5n minus 7. That's 5 times our n. Substitute in place of n, 259. All right. Here we're just gonna need a calculator here. All right. Do not worry. Just the bracket. So 5 open bracket 259 plus. Okay, that's a minus here. So it's gonna be 1,288. 1,288. All right, so that's it. That's how we can determine any term from our linear sequence presentation of our Tn from the nth term. All right, so let us check. I think that will be the last question. Let's see. Now we are given on the part B, they need us to determine which term of the sequence or the number pattern is equal to 753. So as we do understand, remember we calculated our Tn from the previous one. We calculated this and we said it's 5n minus 7. This is what we got. Now we are given another presentation that the same Tn is 753. So find n from there. Just equate the two. Remember what I said, if this one and this one are the same, therefore these two must be exactly the same. 5n minus 7 is equal to 753. Solve for n. You have an equation there. All right, so that's 5n is equal to the minus 7 to the other side, or just add 7 both sides of the equation, so this can cancel. All right, so that's 753 plus 7, which is what? 760. All right, so this is what we have. So what will be our n? Divide by what? By 5. So therefore, our n is 760 as it is here. Just divide by what? By 5. That was going to give us 152. So that's what we have there. This is how these questions can be given as, and it was just like a normal presentation of what we had in our previous grades. So I want you to revise, work out as many questions as you can. We shall meet again in our next class, working with the quadratic. So we shall try by all means cover up the quadratic sequence so that we understand its basics. Just like what you had on an arithmetic or linear sequence, two ways of determining the nth term, we shall see also on the quadratic. So many ways that you can use to determine the nth term. So revise what you are good at, but in as much as you are having your revisions, remember, this is our road to our grade 12 mathematics. So try by all means to adapt to what you're going to be using in your grade 12 mathematics. So that is it. Till we meet again.